Welcome back, guys. Today we're going to be talking about how to troubleshoot TIG porosity. Now, porosity is something that even the most experienced welders come across from time to time. And today we're going to be going over a checklist, so to speak, to help you be able to troubleshoot porosity in your welds and help you eliminate them. So first off, if you're not quite sure what porosity is the culmination of different contaminants, whether they be atmospheric or physical contaminants, getting into your weld and causing your weld to gas off and the weld solidifying and not allowing all those impurities to evacuate before your puddle moves on. So it's going to look something like this if you got some gnarly porosity. So the four primary reasons that you're going to see porosity in your TIG welds is either going to be dirty power, incompatible materials, contaminated materials, or improper gas coverage. So let's get troubleshooting. Now the first thing we're going to look at is dirty power. What I mean by dirty power is anything that's going to cause you to have an unstable arc. Now the first thing we can look at is technically probably more improper power, and if we look at the front of our prime weld right here, we're going to have a positive and a negative port in the front of it. Now improper power would be the leads crisscrossed. So in TIG welding you always want your torch lead to be plugged into the negative port. So double check that, make sure that you've got the right polarity, go in the right direction, make sure your torch is plugged into the negative port. Other examples of dirty powers could be if your geographical location, maybe the power grid isn't good and they don't have good consistent power, that can cause you to flicker. That's an example of dirty power. If you're running a welder off a generator, some generators are not as good a quality and you can get dirty power off of that, where you're not getting a consistently regulated power. The other thing to look at is if you have a bad ground. So check out where your ground's hooked to. If all possible, hook that ground directly to the part. I know it's not very convenient, but that can also cause dirty power and make that arc not be completely stable if you do not have a good solid ground path. The next thing we're going to look at is improper materials. So look at your materials, look at what rod you're using. Maybe you went to the cabinet and you accidentally grabbed a brazing rod, or maybe you accidentally grabbed a filler wire that is meant for oxyacetylene, and that's not going to be a pure enough or compatible material to do most of your general TIG welds. So make sure that you got your compatible rod. Make sure your materials are compatible. I actually had an example of this just the other day. I had somebody at work bring me something that needed to be welded. It was 2 tabs. They had it fixtured onto a plate they wanted, and they had them completely finished and polished. And at first glance, with my safety glasses on, I didn't notice that they had accidentally grabbed an aluminum tab. So I struck an arc up on that, and that aluminum just made a whole bunch of a mess because aluminum is not compatible to weld with steel. So another thing that you can look at for being compatible is your tungsten. Maybe you are using a tungsten that is not going to be as compatible with the material that you're welding. The fourth primary thing that you're going to look at with compatibility is going to be your gas. Maybe somebody accidentally switched bottles and maybe you have a 75-25 on there, and yes, it says argon, but it's not pure argon. You want to make sure you're running a pure argon with your TIG welder. So make sure that all of your materials that you're going to be using are compatible. So the third thing that we're going to look at is our dirty and contaminated materials. Now this can be a variety of things. Whether it's aluminum and that oxide layer is still on there, you want to clean that off. But there are many other things that contaminate your material, whether it be greases or oils or even moisture contaminate your materials. Sometimes if you're in a really humid area or if the chunk of material has been outside for a long time, the moisture that's impregnated in that material can contaminate your TIG weld. So maybe you'll get out a MAP gas or a little propane torch and you can run over your weld joint and evaporate and evacuate as much of that moisture as you can from the weld area, and that could be a cause of porosity and contaminating it. Another thing that could contaminate your material is a mill scale. So you want to get all your mill scales cleaned off. What else do we want to check? We want to check for rust. Rust is a contaminant, or even any coatings that might be on your material. Maybe somebody put some sort of protective layer on the material that is not visible to the eye, but we want to make sure that we can clean that off with a good solvent and maybe even a buff pad or wire wheel or whatever is available to you, but make sure that your material is not contaminated. So the fourth and final reason that you're going to see porosity in your weld is going to be improper gas coverage. Now this is my least favorite thing to troubleshoot because, as you know, sometimes it can be just like chasing your tail. But we're going to start from the top and just kind of run through the things you want to look for to make sure that you have proper gas coverage. First thing you want to look at is your bottle. Make sure you reach over, make sure your bottle's turned on, make sure your flow meter is working, make sure that little ball is floating at the proper height. And that is the next thing. Make sure that you have enough gas. So if you do not have enough argon coverage or flow, that is a good reason that you would get porosity. Also, if you have too much flow. A lot of people don't realize this, but if you have too much velocity or CFH coming out of your cone here, with that velocity, it's going to create an eddy. And as you've seen, if you've seen a smoke machine or just general smoke coming off a fire before, you see when that smoke is moving along smoothly, it's got good coverage over something, but when you get a crosswind, it'll get a little eddy in it, and when that eddy turns, or a little tornado, or whatever you want to call it, as soon as that smoke makes that circle, it is grabbing oxygen and mixing it in, and you're going to get improper coverage. And that brings us to the next thing, which is a side wind. A side wind can very much give you porosity. A little bit of breeze from the side or anywhere is going to blow away that gas coverage and going to definitely be able to cause porosity. Even something to take in consideration is we have our prime weld sitting right here on the bench, and I do not normally have this sitting here because of the fact this thing has cooling fans in it, and we have louvers on the side of it, and even just that little breeze from the cooling fans can be enough to blow away your gas coverage. So make sure your machine is not in line with wherever you're welding. Make sure you don't have a side wind at all. The next thing that can prohibit your proper gas coverage is plugged consumables. So make sure that you can take your lens apart and take your collet body or your gas lens, whatever you're using, and make sure they're not plugged up. Collet bodies are a lot less likely to plug up. Gas lenses are going to plug up a lot more often. So make sure that everything is flowing correctly. Make sure that you have the proper consumables. I've seen where your collets inside are too large a diameter and it does not allow the gas to flow around the collet and be diffused and out through the collet body. So make sure you have the proper consumables there. Another thing you can look for is obstructions in your consumables. After you've been welding for a long time, sometimes you'll notice little beads end up inside your cone here, and that will go right back to making that eddy there. You have that smooth gas flow that's trying to come out, and if you have just the slightest bit of obstruction there, what's going to happen is that gas is going to catch on the end of it, and it's going to create a little swirly there, which is going to scoop up oxygen and other atmospheric things that are going to inhibit proper coverage of that weld. Another thing to look at is your torch properly assembled? Now this is something that I see people do incorrectly quite often. So we want to make sure that we have our collet facing forward inside. We want to make sure that our nylon backer is properly installed and tight up against the thing. Next thing we want to do is make sure that our back cap is loosened, and then we want to run our collet body in. I see a lot of times where people forget to loosen up that back cap and run that collet body in, and the next time they go to sharpen their tungsten, this collet body is not properly seated against the nylon spacer here in the back of the torch, and then gas can get along. You can get oxygen leaking inside of there, and then you're going to go ahead and stick your cone on there. Another thing to look out for is leaks in your system. You can look through, these can be hard to find, and if your torch lines are getting worn out or pinched, maybe you have a hole and it's drawing oxygen in through the lines and you're getting impure coverage over your weld. And the last thing that I would check for is more in the technique. I see this with new welders quite often, and when you're making a weld, you want that torch angle to be right around 15 degrees or so, and you're pushing that weld along. If you're running along and all of a sudden that torch angle gets steeper and steeper, and that arc is going to try to start jumping, and that arc is going to get wider than the total width of your gas coverage, and you're going to get improper coverage, and therefore you're going to get porosity out of it. So make sure you have a proper torch angle and you're moving along at a proper speed. So thanks for watching, guys. Hopefully this was helpful. Hopefully this helps you troubleshoot any porosity that you might be having in your welds. Thanks for watching. Make sure to subscribe, make sure to hit that like button, and go build some.